This is Dr. Holt. This video is on the WebAssign problem having to do with a rock that is dropped from a cliff where it covers 1/3 of its total distance to the ground in the last second of its fall. Air resistance is negligible. How high is the cliff? I drew a picture here. I set VI1 being equal to 0, V initial 2. So what I'm doing here, I'm going to work within just this lower 1/3. Now I let this be 1/3 L here. If this is 1/3 L here, this distance from here to here would be 2/3 L, where this total distance here is going to be L. I write down what I know. I know my time is 1 second. I know my delta y is negative 1/3 L. I know my acceleration is negative 9.8. I do not know V initial 2. Now I write this as V initial 2 because I want to know what the initial velocity is going to be right here at the top of the 1/3 L. I go back to my kinematic equations. I'm going to use that delta y is equal to VIT plus 1/2 AT squared. I go ahead and put in the values that I know for delta y, which is negative 1/3 L. So the only unknown I'm going to have here is VI2. I solve for that in terms of L, and I get 4.9 minus 1/3 L, which will be the velocity right here. Now what I'm going to do is I'm going to jump up here. I'm going to work within this area here. Now if VI2 was 4.9 minus 1/3 L, then working within here, this is going to become the final velocity 1 between here and here. So the final velocity here is going to become this value here, which I write here. The V final 1 is 4.9 minus 1/3 L. Alright, I write down what I know and what I don't know. Again, I know delta y now is going to be negative 2/3 L. I know my V initial here is going to be 0 because it's being dropped. I know my V final, and I know my acceleration. The only thing I don't know is time. So what I'm going to do, I write down my 3 kinematic equations. I'm going to stay away from the ones that have time in them because I don't know what time is. I'm going to come to this equation right here. I'm going to put in the information I know. V final is going to be my 4.9 minus 1/3 L. I'm going to square that. VI is going to be 0. Minus 2, 9.8 times my minus 2/3 L, which is my delta y. Okay, going to have to FOIL it here, and then basically take this, move it to the other side, and you're going to get a nice quadratic equation. Okay, you can solve that using the quadratic equation or quadratic formula, or you can graph it, either one. I just ran a program that I had my calculator that solved the quadratics, and I got L as 145.5 m. I think the WebAssign answer is 146 meters. But that's how, again, that's how you would solve a problem like this. This would be a great test problem, so I would make sure I know this, and I would know how to do it with values other than just 1/3 and 2/3. All right, best of luck.